Hello, welcome to this Tech Talk where we are going to talk about how to apply HPE security solutions to make the Internet of Things more secure. My name is Angelo Brancato and let's get started. So, what is the Internet of Things? Obviously, in enterprise environments, it is a network of interconnected physical objects and devices, like sensors and actuators, within vehicles, buildings, factories, airplanes, and wherever else data about a specific environment can be gathered and analyzed to improve the efficiency of the respective business and eventually save money or increase revenue with complete new business models. But at the end of the day, it's all about collaboration and analytics. Collaboration is achieved by interconnecting and bridging the different protocols of embedded hardware, firmware, and software that control or monitor the physical devices. We call that machine-to-machine communication, and also connecting that operations technology out there with decentralized enterprise information technology to make use of the data. And making use of the data is absolute key to interpret and understand the data patterns and turn that knowledge into intelligence to gain new and valuable business insights. But such a highly complex construct will also enlarge the attack surface for cyber attacks. And unfortunately, as we all know, just one single breach is enough to destroy the whole business model. So what are the main IoT building blocks that need to be protected and secured to avoid that? The IoT endpoints are distributed sensors or actuators, either mobile or stationary, but always connected to the IoT cloud via the internet or a private network. IoT endpoints can connect directly or via an edge computing device. IoT endpoints can also communicate to each other. As described, we call that M2M communication. The edge computing device is a processing unit sitting on the same physical entity as the IoT endpoints. For example, in the car, in the turbine, on the airplane, or in the building. It translates the OT protocol, like SCADA, to an IT protocol, like TCP/IP. It will ingest and pre-process the data and do in-band or real-time analytics. Basically, it will take on-site or on-vehicle decisions where the IoT cloud is too slow due to latency. The connectivity layer provides ubiquitous, reliable, and secure communication technology for all endpoints and edge devices, wirelessly and wired. The IoT Cloud Platform is not only responsible for operations and control of the entire IoT infrastructure, it is also a central data storage, collecting and enriching the IoT data and doing big data analytics on it. Here's where we gain new business insights through deep machine learning. And the visualization layer, which consists of applications that present and visualize the findings and key performance indicators, and also provide an open ecosystem for partners and suppliers. So to implement a secure IoT infrastructure, we must at least protect those entities and its containing data, applications, communication, and users. There are many and diverse attack scenarios and risks for an IoT infrastructure. In this session, we will focus on securing the data. In fact, we will learn how to protect the data throughout its whole life cycle, on creation, in transition, at the time of analysis, at rest, and on access. 2. Neutralize the risk of data leakage, unauthorized data access, and unauthorized data manipulation. Apart from data leakage, the most prominent other risks are that applications on the endpoints and/or edge devices can be compromised through software vulnerabilities. Rogue endpoints can be sneaked into the network, rendering the data useless or causing unwanted behavior. The network infrastructure itself can be prone to man-in-the-middle attacks, deny-of-service attacks, and unauthorized access. Vulnerable applications, of course, play also a critical role in the cloud and backend security, as most of the targeted attacks focus on application vulnerabilities to infiltrate the network. The HPE Security Products business unit, which is part of HP Software, provides solutions to address these risks to protect what matters: the data, applications, users, and the communication. Communication and network security is provided by HPE Aruba. With the Aruba wired and wireless network security solutions, we can not only make sure that the network layer is secured, but also make sure that only authorized and authenticated applications on all entities are able to communicate to the backend. Data security is provided by HPE Security Data Security, including Atala Enterprise Secure Key Manager for key management and Voltage Secure Data for data end-to-end protection. This TekTalk will be focused on voltage secure data and how we immunize the data in itself, no matter where it is transported, stored, or processed. HPE Security Fortify provides static and dynamic application security testing and software security assurance. Software is omnipresent throughout all layers in the IoT infrastructure, and it is the biggest attack surface. Thus, it needs to be secured above all. And HPE Security ArcSight, our security intelligence solution, providing security information and event management to primarily detect and respond to security threats in real time. Please go to hpe.com to find out more about the HPE security solutions. To build security into the software fabric as an integral and intrinsic part, the HPE security solutions can integrate into the HPE application delivery management and IT operations management portfolio to, as said, build security into the application lifecycle and make it not an afterthought option, but make it an integral part from when the application is delivered throughout its operation lifecycle until it is decommissioned. Okay, now let's talk tech and see how we can protect IoT data with HPE Security Data Security. Let's say we have two users. Let's call them Rob and Agnes. They will enter data into a system of client computers, networks, storage, cloud, etc. But one condition must always be true. Only Rob and Agnes are authorized to see the original clear text data. All other entities in between Rob and Agnes that transport, store or process the data must do whatever they do with the encrypted and protected version of that data. HPE Voltage Secure Data provides two mechanisms to do so: Secure Stateless Tokenization or SST and Format Preserving Encryption or FPE. In this session, we will be focusing on format preserving encryption. The data that Rob enters into his mobile device gets de-identified right after entering it into the mobile device by the mobile device. And so, the mobile device itself, the backend system, and every entity in between Rob and Agnes will work with the encrypted and protected version of that data that still looks like the original data. In other words, the format of the data has not changed, and so no database schema in between Rob and Agnes needs to be changed. FPE will also maintain referential integrity throughout the data lifecycle, so that Agnes can recover the original data at any time after authenticating herself against the system. If we map that functionality to an IoT use case, we could choose to have connected trucks that, amongst other data, send GPS trajectory data to the IoT cloud. That GPS data needs to be protected in between the endpoints themselves, the trucks, and the visualization layer on the other end due to regulation. So we implement HPE Voltage Secure Data format preserving encryption on the truck's edge computing device to de-identify the GPS data and sending it on to the IoT cloud platform, where it will be processed together with all other telemetrics. Only authorized users are able to access the original trajectories at any time. Now let's see how that looks like in a proof of concept implementation. In this demo, I prepared a mini app that will simulate the application on the IoT edge computing device on the truck that receives the GPS data from the truck's electronic control unit. This application makes use of the HPE Voltage Secure Data Simple API, meaning I can call the Secure Data FPE API from within my Java code to de-identify the GPS data. As you can see in this code snippet, to do so, I import the SecureData library, created the SecureData objects, and then simply call the FPE method protect on the GPS data to protect the data. And later on the backend application, I can call the FPE method access to access the original data. The edge computing device got the keying material from a SecureData web server in the IoT platform DMZ after authenticating itself via its private key. Subsequently, the data is sent encrypted to the IoT cloud, where it can be decrypted on demand by an authorized system or person. Okay, let's go back to the mini app, get the truck going and replay some GPS data. I downloaded some real-world GPS trajectories from the Microsoft GeoLife project and will present that data to my edge computing application on the truck by clicking the Start button. And we see GPS data is coming in and the edge computing mini app called the SecureData API to apply format preserving encryption on it before sending the data out to the IoT cloud. Now let's stop the truck and export the original GPS data to gpsvisualizer.com to see the original route compared to the protected GPS trajectories. Importing that file into gpsvisualizer.com, we can see that the truck drove a road in Beijing. Now let's import the protected data that still looks like GPS data. And of course, the trajectory makes no sense at all. This is what an attacker or malicious insider would see after stealing the data from the backend database. And now let's open up a client application that uses the mentioned access method within the simple API to get the original data back as an authorized user. Today we discussed how to apply HPE Security data security to an IoT infrastructure to protect the data. Stay tuned for the next IoT Tech Talk, where we will touch on the next building block towards a secure IoT infrastructure. Thanks for watching. Ciao.